Power electronics. Chapter 1. Introduction. Outline what is power electronics? The history, applications. A simple example about this course. What is power electronics? Definition. Relation with information electronics. The interdisciplinary nature. Position and significance in the human society. Definition: power electronics. A more exact explanation is the electronics applied to conversion and control of electric power. Range of power scale: milliwatts, MW, megawatts, MW, gigawatts, GW. The primary task of power electronics is to process and control the flow of electric energy by supplying voltages and currents in a form that is optimally suited for user loads. Conversion of electric power. Converter. Output. Input. Control input. Other names for electric power: converter, power converter, converter, switching converter, power electronic circuit, power electronic converter. Two types of electric power. Changeable properties in conversion: DC direct current, magnitude; AC alternating current, frequency, magnitude. Number of phases. Classification of power converters: DC, AC, AC to DC converter, rectifier, AC to AC converter, fixed frequency, AC controller, variable frequency, cycloconverter or frequency converter, DC to DC converter, chopper, DC to AC converter, inverter. Power output. Power input. Power electronic system. Generic structure of a power electronic system: power converter, power input, power output, control input, feedback/feed forward, feed forward/feedback, controller. Measurements of output signals, measurements of input signals. Reference. Commanding control is invariably required. Power converter along with its controller, including the corresponding measurement and interface circuits, is also called power electronic system. Typical power sources and loads for a power electronic system: converter, power input, power output, load, source, electric utility battery, other electric energy source, power converter, electric motor, light, heating power converter, other electric or electronic equipment, feedback/feed forward, controller. Reference. The task of power electronics has been recently extended to also ensuring the currents and power consumed by power converters and loads to meet the requirement of electric energy sources. Relation with information electronics. A classification of electronics by processing object. Electronics. Information electronics, to process information. Power electronics, to process electric power. Electronics. Vacuum electronics, using vacuum devices. E.G. Vacuum tubes devices. Solid state, electronics, using solid-state devices. E.G. Semiconductor devices. Applied electronics, application of electronic devices to various areas. Physical electronics, physics, material, fabrication, and manufacturing of electronic devices. Other classifications of electronics. The interdisciplinary nature. William E. Newell's description. Electronics. Devices, circuits. Power. Static and rotating power equipment. Power electronics. Continuous, discrete control. Power electronics is the interface between electronics and power. Relation with multiple disciplines. Power. Electronics. Systems and control theory. Circuit theory. Signal processing. Simulation and computing. Electronics. Solid-state physics. Electromagnetics. Power systems. Electric machines. Power electronics is currently the most active discipline in electric power engineering worldwide. Position and significance in the human society. Electric power is used in almost every aspect and everywhere of modern human society. Electric power is the major form of energy source used in modern human society. The objective of power electronics is exactly about how to use electric power, and how to use it effectively and efficiently, and how to improve the quality and utilization of electric power. Power electronics and information electronics make two poles of modern technology in human society. Information electronics is the brain, and power electronics is the muscle. Mercury arc rectifier vacuum tube rectifier thyratron. The history. Application of fast-switching fully controlled semiconductor devices. Invention of thyristor. GTO. GTR. Power MOSFET. Thyristor. Microprocessor. Mercury arc rectifier vacuum tube rectifier thyratron. IGBT. Power MOSFET. Thyristor. DSP. Power diode thyristor. Late 1980s. 1900. 1957. Mid-1970s. Prehistory. First phase. Second phase. Third phase. The thread of the power electronics history precisely follows and matches the breakthrough and evolution of power electronic devices. Applications: industrial, transportation, utility systems. Power supplies for all kinds of electronic equipment. Residential and home appliances. Space technology. Other applications. Industrial applications. Motor drives. Electrolysis. Electroplating. Induction heating. Welding. Arc furnaces and ovens. Lighting. Transportation applications. Trains and locomotives. Subways. Trolleybuses. Magnetic levitation. Electric vehicles. Automotive electronics. Ship power systems. Aircraft power systems. Utility systems applications. High voltage DC transmission HVDC. Flexible AC transmission FACS. Static VAR compensation and harmonics suppression, TCR, TSC, SPG, APF. Custom power and power quality control. Supplemental energy sources. Wind, photovoltaic, fuel cells. Energy storage systems. Power supplies for electronic equipment. Telecommunications. Computers. Office equipment. Electronic instruments. Portable or mobile electronics. Computer. Server. Telecommunication. Residential and home appliances. Lighting. Heating. Air conditioning. Refrigeration and freezers. Cooking. Cleaning. Entertaining. Applications in space technology. Spaceship power systems. Satellite power systems. Space vehicle power systems. Other applications: nuclear reactor control. Power systems for particle accelerators. Environmental engineering trends. It is estimated that in developed countries now 60% of the electric energy goes through some kind of power electronics converters before it is finally used. Power electronics has been making major contributions to better performance of power supplies and better control of electric equipment, energy saving, environment protection. Reduction of energy consumption leads to less pollution. Reduction of pollution produced by power converters. Direct applications to environment protection technology. A simple example: a simple DC-DC converter. Example: input source, 100 volts. Output load, 50 volts, 10A, 500 watts. How can this converter be realized? Dissipative realization. Resistive voltage divider. Dissipative realization. Series pass regulator. Transistor operates in active region. Use of a SPDT switch. SPDT, single pole double throw. The switch changes the DC voltage level. Addition of low pass filter. Addition of, ideally lossless, LC low pass filter, for removal of switching harmonics. Choose filter cutoff frequency F0 much smaller than switching frequency Fs. This circuit is known as the buck converter. Addition of control system for regulation of output voltage. Major issues in power electronics. How to meet the requirement of the load or gain better control of the load. How to improve the efficiency for reliable operation of power semiconductor devices. For energy saving. How to realize power conversion with less volume, less weight, and less cost. How to reduce negative influence to other equipment in the electric power system and to the electromagnetic environment. About this course, 4 parts of the content. Power electronic devices, Chapter 2 and 9. Power electronic circuits, Chapter 3, 4, 5 and 6. Control techniques, Chapter 7 and 8. Applications, Chapter 10. Relation with other courses. Fundamentals of analog, digital, electronics. Prerequisite course. Control systems for electric drives. Continuing course. Power electronics.